Welcome to This Explainer. Today, we're diving headfirst into the sudden, literally massive rise of autonomous AI agents and how the entire tech industry is practically scrambling to secure them. I'm super excited to guide you through this because honestly, the shift we're seeing right now, it's absolutely revolutionary.
So to really wrap our heads around this massive paradigm shift, we've got to start with one fundamental question. What actually happens when we take the training wheels completely off our artificial intelligence? Up until recently, AI was pretty much a passive tool, right? You ask it a question, it spits out an answer, and then it just goes back to sleep. But what we're talking about today is a world where the AI doesn't wait for you. It acts, it plans, and it executes on its own.
Here's our roadmap for unpacking all of this today. We'll hit the 4 waves of AI, enter OpenClaw the lobster, look at how always-on agents actually work, jump into some real-world agent applications, cover the security risks in the chaos, and wrap up with securing AI using NemaClaw.
All right, kicking things off with Section 1, the 4 waves of AI and the path to autonomy.
Just take a look at the wild compression of time we've experienced here. Think about it. Predictive AI took literally years to become mainstream. Then, generative AI hits the scene and it conquers the world in a matter of months. Right after that, reasoning AI arrives and we measure its adoption in weeks. And now? Well, now we're in the era of autonomous AI. And this phase doesn't even operate on a normal timeline. It's continuous. The gap between each major technological leap isn't just shrinking anymore, it's practically evaporating right in front of us.
Moving on to Section 2, let's talk about the viral protagonist in all of this. Enter OpenClaw the lobster.
250,000. That's the mind-blowing number of stars the OpenClaw project racked up on GitHub in just 60 days. To put that completely wild number into perspective, it actually overtook React, which is literally one of the foundational building blocks of the modern web, to become the most starred software project out there. It was an absolute undisputed phenomenon, bringing in over 2 million visitors to their community dashboards in a single week. Pure viral chaos.
And this right here was their calling card. Created by developer Peter Steinberger, OpenClaw gave developers exactly what they'd been practically begging for, a local, completely unbounded AI assistant. The lobster way, as the community lovingly called it, basically meant you could run this agent natively on your own machine. No expensive cloud bills, no waiting on external API calls. It could automate your WhatsApp, Slack, Discord, and literally control a live digital workspace right there on your desktop.
Which brings us to Section 3. Let's break down how these always-on agents work using the heartbeat model. So, let's contrast the old with the new. On one hand, we've got traditional on-demand chatbots. You write a prompt, it does a thing, and then it stops. It's basically a really smart vending machine. But on the flip side, we have these always-on claws. These agents run on this continuous, persistent background heartbeat. Imagine it waking up at regular intervals, checking its to-do list, figuring out what needs doing, and then either executing the task or waiting for the next cycle. It's totally independent and only flags a human down when it hits a roadblock and needs a major decision made.
But you know, that continuous heartbeat, it comes with a massive cost. Because these autonomous agents are running nonstop and planning across long periods of time, they crank the inference computing demand up by a staggering 1,000 times compared to standard reasoning AI. 1,000 times! Every new wave of AI multiplies the compute we need, but having an AI constantly thinking, plotting, and checking 24/7, that's a completely different ballgame for a hardware infrastructure.
Okay, Section 4. Let's look at real-world agent applications, moving from mere suggestions to actual actions. This huge leap from just getting suggestions to the AI actually taking action is happening everywhere right now. Take the financial sector, where agents are independently monitoring complex trading systems and flagging weird events before the humans even have their morning coffee. Over in pharma, they're sweeping vast amounts of scientific literature overnight and updating databases, something that used to take human researchers weeks to pull off. Or engineering, where agents are just churning through thousands of parameter stress tests while the team is literally at home sleeping.
If you want to see the real-world impact of this, just look at IT ticket resolution. Platforms like ServiceNow are unleashing autonomous models to automatically handle a jaw-dropping 90% of IT tickets. No humans involved. Zero. The agent diagnoses the server issue, applies the fix, and only kicks it up to a human if it's a completely novel problem. It's taking resolution times from agonizing hours down to mere minutes. A total game changer.
But it wasn't all smooth sailing. Let's hit Section 5, security risks and chaos in the wild west of open source.
Okay, first, we've got to talk about the genuinely hilarious cultural clash this caused. The open source community turned into a total circus. Check out this actual Reddit thread. On one side, you have confused retro gamers on the OpenClaw subreddit trying to troubleshoot a pirate platformer game from 1997 called Claw. They're complaining about resolution scaling, and in that exact same thread, you have AI developers, completely oblivious to the gamers, posting stuff like, "Are your OpenClaw agent working fine?" It perfectly captured the messy, totally uncoordinated Wild West of open source AI dropping onto the internet.
But jokes aside, there was a very real, frankly terrifying problem brewing here. Security researchers were practically screaming from the rooftops. Because giving an autonomous open source agent full native access to read, write, and execute code on a host machine, that is a catastrophic liability. Just imagine an unpatched server running some sketchy, modified community version of an AI, and suddenly it decides to start sending out unauthorized emails or overwriting live databases on its own. When an agent like that makes a mistake, the real-world consequences are severe.
And that perfectly sets up Section 6, securing AI with OpenClaw, and finally taming the agent. The gold standard solution to this absolute chaos is sandboxing. Basically, sandboxing is how you put severe restrictions on an autonomous agent using tools like Docker, so it can't just wreck your underlying operating system. You explicitly define exactly what the AI can see, what files it's allowed to touch, and what specific APIs it can use. You're taking this wild, unbounded lobster and dropping it into a very secure, completely transparent, bulletproof glass tank.
So, to make this actually viable for serious enterprises, NVIDIA rolled out OpenClaw. Think of it as a blueprint that grabs that wild OpenClaw project and wraps it in military-grade security. Step 1, run it inside an OpenShell sandbox. Step 2, utilize open, safe Nemotron models running locally so your private data never leaks. And Step 3, run the whole shebang on highly secure, dedicated local DGX hardware. That way, it gets the massive 24/7 compute power it desperately needs completely safely.
The huge takeaway here is that with just a single command, organizations finally have an auditable, lockdown framework. They maintain 100% visibility over what the AI is doing, seeing, and accessing at any given second. They get all those amazing benefits of an always-on, self-improving digital worker, but without the nightmare scenario of an unsupervised robot going rogue on their corporate network.
As we wrap up this explainer, I want to leave you with something to chew on. We are officially closing the chapter on waiting for human input. We've stepped into a reality built entirely on continuous, autonomous actions humming away in the background of our businesses and our pockets. The tech is here, it's out in the wild, and it is running as we speak. But as we hand over the keys to these always-on agents, we really have to ask ourselves, when our machines stop waiting for us, who is truly governing the heartbeat of our digital lives? Thanks so much for joining me on this deep dive, and keep your eyes wide open. Things are moving impossibly fast out there.